This is the first section of Chapter 3, Section 3.1, and in this section we're going to find prime numbers, greatest common factors, least common multiples of whole numbers. So the first thing I want to review with you is what factor means. And factor means to take a given number and break it down into smaller numbers that all multiply together to turn into your original number. So for example, the factors of 6 are 3 and 2 because 6 equals 3 times 2. Now, the next thing we need to talk about is what actual prime numbers are. Prime numbers are numbers that are only divisible by 1 and themselves. The following numbers are a list of prime numbers from 1 to 40. So we have 1, 3, 5, 7, 11, because the only things that divide into these are themselves and 1. Let's make a list of the rest of them. 13 is the next one, 17, 19, 23, 29, 31, and 37. Numbers that aren't prime are called composite numbers, and composite numbers can be divided by other numbers other than 1 in itself. So 2 is the smallest one, followed by 4, 6, 8, 9. Now it's not an even odd number situation, you can see that. 9 is divisible by 3 and 9 and 1, so that automatically makes it a composite number. And then 10. Our next one would be 12, 14, 15, 16, 18, 20, again an odd one, 21, 22, 24, 25, 26, and then again 27. And there are more composite numbers you can see than prime. Next thing we'll talk about is what's called prime factorization. Prime factorization is to take a given number and break it down into factors that are only prime numbers. The actual list of individual numbers in the list is the prime factors. So for example, the prime factors of 12 are 3 times 2 times 2. This is actually prime factorization right here. And the factors themselves, the prime factors, are 3 and 2. So in this next example, we are going to find the prime factorization and write what the prime numbers are. So the way, and on the side here I have some steps that will help you do this when you're doing questions on your own. So it says, write the prime factorization of 150 and what are the prime factors. So you're going to start by writing down 150. And there's going to be different ways you're going to discover to do this, but there's a couple basic ways you can always try. And you want to see, first of all, if 2 goes into the number you're looking at. And if 2 doesn't work, then you go and try 3 or 5. You want to look at prime numbers to begin with, if you can. And when I look at this, I notice that 2 times 75 will work. So I'm going to break them apart with little branches, we're going to call this. It's going to be a factor tree when we're done. And this means 2 times 75. And what we're going to do is we're going to circle the prime number, which is going to be this 2. And then we're going to go back to 75, and we're going to treat that like a brand new number. And we're going to find a number that goes into 75 that's prime. Well, 2 doesn't work. 3 will work, and that's going to be 3 times 25. And again, the way I teach it is I circle the prime numbers. There's different ways to do it. 25 is not prime. It can be broken down into other numbers. And if you look at it and think about it for a minute, the only way to do it is 5 and 5. And both of these are prime numbers, so I'm going to circle both of them. Now this question asks for two things. The prime factorization first of all. And the prime factorization is all of the circled numbers multiplied together. So 2, and we're not going to use a times sign in this chapter because I don't want you confused with x's and times signs. We're going to use the dot. 2 times 3 times 5 times 5. The next question asked for what are the actual prime factors. Well, the prime factors are, there's a 2, there's a 3, there's a couple of 5s, but all I care about is that there is actually a 5.